We're calling you from Seattle, Washington, and Chicago, Illinois. And today we're going to talk about Qmat, which is a new quantum compute layer for Apache Mahout. And so we're happy to be here. We were both tied up with family obligations, so we were sorry not to be there in person, but we're happy to be here with you on the internet. We'll be talking today about this list, who we are and who we aren't, and something about the project. So introduction to Mahout itself, a short introduction to quantum computing, just to bring everybody up to speed on that new development. The motivation for putting a quantum layer into Mahout, then a little bit of a catch up on what distributed matrix arithmetic looks like, how Mahout has tackled that problem over the years, and why it makes sense to put a quantum layer into Mahout. Then Trevor will take over and talk about an overview of this new interface, Qmat. We'll have a short demo with a notebook showing launching a Qmat job from our GitHub repo directly into Colab. A little bit of next steps on the projects, and then ways that people can get involved in the project, use the software, become a collaborator, and all that. And then we'll have time for a QA at the end. So a little bit about who we are. I have been working on Apache Mahout for over 10 years now. I wrote a chapter in the book for Springer on Mahout several years ago. Been doing data and software engineering for quite some time. Currently open to work opportunities, so please reach out. I think my contact info is available. I have some personal stuff. I have 2 kids, 2 dogs, and 2 cars in Portland. I'm just mentioning the cars to offset Trevor's car-free existence in Chicago. So we have a sort of a carbon offset system going here. I do a lot of music. Used to do a little bit of amateur radio and keep myself busy with some hobbies, including gardening and rose tending. And then Trevor?
Sure. I'm Trevor Grant. I've spoken at Berlin Buzzwords a few times, and as Andrew said, I am super bummed that we couldn't make it. It's an awesome conference. Berlin in June is just a lot of fun. Yeah, unfortunately, that is the way the world works sometimes. So here we are. I'm a PMC also on Apache Mahout, author of Kubeflow for machine learning on O'Reilly Media, various papers on this, that, and the other, but no papers on quantum. I've got 2 little boys, 1 and 3. I used to have a fun picture of them eating pizza, but I lost it. Car free since 23. Actually, car free since 22, and that's probably not going to land in Berlin as well, because y'all have trains and adequate public transportation, and it's not legal to kill people in the street for having the audacity to not be in a car. But in North America, that's not how it is. So it's quite the accomplishment, and I try to push it. But at 22, car free since 23 because it rhymes. Car free since 22 doesn't roll the tongue so easy. But at any rate, as always, a special thank you to IBM for its continued patronage of my artistic endeavors, which currently I'm working in the AI Alliance, which is a really, really cool conglomerate of a bunch of companies. I'm happy to talk more about that, but not exactly related to this. And they didn't pay for me to fly to Berlin, so I don't feel compelled to give too much of a backstory on them.
Yeah, but feel free to reach out if you want to get involved.
Please. Yeah.
We got a lot of projects going on. We could talk about GoFan and some other stuff offline if you want. Cool, thanks. And then just in contrast, this is a little bit about who we are not. So, and this sets up the motivation for what Qmat's meant to be. So you want to take that?
Sure. As I said, we're not quantum researchers, and we don't have PhDs in quantum mechanics or physics or any PhDs at all, really. At least I don't. Andrew, you don't have a PhD.
No.
Okay.
No.
We're also not authors on any notable papers on quantum anything. Again, I've written a couple. I think, Andrew, you have too, but nothing related to quantum. Who we are software engineers who have a deep history and understanding of why it's important to be able to abstract over different backends, and not written here, but also, so IBM's Qiskit is doing this, but it's problematic to have a vendor being the person who writes the abstraction layer over everything else for various perverse incentive reasons. So that is who we are, not.
Yeah, this is so the point being, Mahout has a history of being a machine learning library, recommender engines, lots of use case driven purposes for machine learning and AI. But it started out as a linear algebra framework, and it had tools for recommender engines. It had tools for doing clustering of users and other items, item similarity. So all the three C's, co-occurrence, clustering, that were 10 years ago, what we were calling machine learning. And in making that useful for people, one of the needs that arose was to have a mathematically expressive domain-specific language similar to MATLAB or Mathematica, so that people wouldn't have to relearn any multiple frameworks on the back end to do their machine learning and write algorithms, as well as so it provided a unified front end for writing machine learning, as well as a front end for back end. So you can run your jobs on your CPU. At the time, you could run it inside your JVM. You could run it in a GPU. You could take advantage of CUDA and Vienna and other things like that. And that way you could write code one time and port it from Spark or Flink or H2O, whatever you were going to be using. And you could also just deploy it on whatever hardware you wanted. So Mahout's reason for being developed into a way to simplify writing algorithms so that you could focus on the mathematics behind it instead of remembering separate APIs and learning how to use different backends and deal with all of the data transformations and where things live in memory that you'd have to do if you wanted to do this stuff from scratch. So a little bit of history. It started as a sub-project of Lucene, which is a NLP and search library. It included analytics with clustering and other things. It became a top level project in 2010. It had Taste donated by Sean Owens, which was a full recommender engine. In 2015, that's when we built up that DSL for doing matrix math with simplified syntax. We moved on from Hadoop MapReduce in 2017, a little late in the game, but it became obvious that writing machine learning algorithms that needed to do full table scans and do their operations in an iterative way was wasteful and not efficient. 2022, we started reaching out into the community for other ways to deploy Mahout and do machine learning. So Zeppelin was a notebook system that was popular then, and Trevor actually included that as an engine in Zeppelin so that we could run workloads inside of notebooks. And most recently, last year, adding the quantum computing interface, Qmat, that's where we're putting all of our efforts now. Just so a simple introduction to quantum computing for anybody who hasn't experienced it or worked with it. It is not science fiction, even though this is the hardware it runs on, and this to me looks very science fiction like. This is a quantum computer in the world. And these things are provided. I mean, we get the question all the time. Well, I thought quantum was still fake and still coming. And the answer actually is that lots of vendors, AWS, IBM, Honeywell, I think Google's works. A lot of providers have cloud instances of quantum simulators as well as real hardware that you can run real workloads on now. So it is real. and it is worth looking at. And so, just to get up to speed on some quantum stuff, the the advance with quantum is that you're not limited to two states for each transistor. You can, depending on how many qubits you have in your computer, you have multiple, 2 to the nth potential states. So it's beyond the scope of this to go into that, but it's very interesting, and there are lots of use cases developing in the market where being able to take advantage of this flexibility is actually game changing as far as efficiency, and we believe that it's a good thing to start getting into. And the reason that this popped up on our radar, I think Trevor noticed that when you look at quantum states, these look very much like basis vectors. And so this notation aside, this is physics notation. So for math people, usually we sort of glaze over when physics people show us their math. But this is a representation of a complex term times a zero, a one-dimensional basis vector, plus another complex term times another basis vector. And in that sense, you just have a vector in the end. So, for instance, this is the 0 vector and this is the 1 vector. So these looked to us very much just like basis vectors from matrix math. And when we looked at how the math for quantum was performed, it's chained multiplication of matrices. And so we felt like it was a good fit for Mahout because that was the bread and butter of the project. So for instance, you have a vector here times the identity matrix. What you have is, after you do the arithmetic, you just have the original vector again. So we felt like it was a good fit. And that's the motivation for putting quantum into Mahout. We have in Mahout, the core of what it's good at is matrix arithmetic, linear algebra. It's backend agnostic, so you can choose any hardware to run it on. And then we have simplified math DSL. And so what Mahout is really good at is managing large vectors, large matrices, and doing arithmetic on them. And so for quantum, we felt like that was a perfect fit because like I said, all we do when we build circuits up is we slap matrices together in order and do some multiplication, and then we get our computation. The difference here is that the vectors and matrices are complex valued instead of binary or real. So in machine learning, typically people have binary matrices or real value matrices, and for us, complex numbers are the same thing. And so here's a conceptual architecture to show how Qumat relates to Samsara, where Samsara was a layer providing access to Spark, Flink, H2O, and others. And Qumat is just a new layer here that provides a front end to IBM's Qiskit, Google's Circ, and AWS's Bracket. And so that is the overview of how it's meant to operate. Here's I'll probably blow through these slides a little bit so we can get through it, but here's the syntax that we're talking about. And this is relevant because eventually, while we're, in our next steps, we'll be making this DSL operable for quantum as well. So the simplification that Samsara provides is, instead of having to dig up what the syntax is for, say, MLlib to do a transpose of A multiplied by itself, where you have to look up the method and you have to look up this method, you have to keep track of what it's returning. Here you do more simplified math like arithmetic, like you would in MATLAB or something like that, where you say A.T, which is intuitive, and then you have a matrix multiplier by A. So that's how this is meant to be. And so for people who are researchers and looking through papers and seeing this type of this type of equation here for stochastic PCA, for instance, it looks very complicated, and to translate that into multiple in any number of machine learning libraries, you would have to look up the syntax and do that. What we meant to have here is something simple, where you have B times B transpose minus C transpose plus chi dot transpose times itself, etc. So that's the motivation here for Samsara. And this is, I'll blow through this stuff, but this is just some examples of how to create matrices. Very MATLAB-like. You can make a sparse matrix where you have indexed locations. You have simple arithmetic here. You have increments, dot and cross and multiply. So all these things should look simple and familiar for people who are MATLAB type people. And here's just an example of how Mahout does its arithmetic. So this is an optimization of A transpose A. You take your matrix A, you slice it into its rows, you transpose A into corresponding columns. And to do this multiplication, then this can be distributed across your backend, where you multiply this column transpose times that column or that row, plus this column transpose times that row, this column transpose times that row, and then finally the last column times that row. So that is what we have in Mahout, and then we are applying that to the matrix arithmetic that's in quantum compute. So any questions on that? Afterward, I know there's an online way to get questions to us. So Trevor, you want to get into Qumat?
Yes. So now that you have a little bit of the background on the Samsara project, that was another, in addition to the linear algebra heritage of Mahout, also being able to abstract over multiple backend frameworks. And so this is not an exhaustive list. The first three we have already implemented. The second three we haven't. And there's probably another 100 of them out there. And again, Qiskit is making efforts to abstract over everything. But then the problem is, all right, you're using Qiskit, but also IBM owns that. And I work for IBM, but you've got a bit of a weird situation where the open source, the people owning the open source also want to sell you something. So you got to be kind of suspicious there. Whereas the Apache Mahout, we are open source, owned by a foundation. We have no quantum to sell you. So yeah. But yeah, the multiple frameworks and backends is a core value of our project. So the value add there is that with one interface and no or very minor code changes, your algorithm will run. It should respond or return the same answers, whether you're running on Qiskit, Bracket, Circ. And this is very valuable for maintaining vendor independence and avoiding vendor lock-in, which some people think is a thing of value.
Yeah, so a simple config change in your software, then you can deploy it to multiple different backends.
Yep. Qumat current state, and something I noticed that was not on these slides, or I guess it's kind of on this one. We've been talking a lot about Scala, and Samsara was a Scala implementation. For the quantum Qumat stuff, we have pivoted to Python, and that is more to do with just the way the world's going. Scala, its support has somewhat fallen off over the years and given way to Python for the newer stuff. A lot of that driven by the AI, but and a number of other things too. But yeah, so this is, even though we've been talking about Scala, Qumat is a Python implementation. Currently we have, all right, I want to say, we were looking at this earlier. I think this slide is already out of date.
It is.
We do have the Qiskit, Circ, and Bracket, like I said. Draw and measure, I think all three of those are implemented at this point. We released 04. We are working on, somebody did an unauthorized PyPy release, so that does exist out there. We just got the Qumat name back from PyPy the other day, so coming soon. We'll have version when you do a pip install Qmat, you'll get the version 4. And the next steps and the places we're going with this is, again, focusing on quantum machine learning and implementations of quantum machine learning algorithms. So I believe there are still some things that we need. We're not there yet, basically. There are other building blocks that need to be in place before we get these quantum machine learning algorithms, but that is the North Star that we are chasing. The logic gates, we do have those. Logic gates are really, really like table stakes for any kind of quantum stuff. And that's what makes quantum computing a little bit more less approachable than classic computing. And classic computing, if you get on Python, you can go from 0 to hello world, and you don't have to think about AND gates and NOR gates or gates, basic level gates. And the quantum computing, that is the first thing you are going to have to deal with. And this is a really, really awesome little chart that maps these various gates to the matrix representation of them. And these are how, and then on the left is how they're all applied as methods in Qmat.
Yeah, so each of these gates, a poly-X gate basically takes this matrix and puts it into the circuit as something to be multiplied by. So it's Qmat's simplified a lot of this stuff. So it looks hairy, it looks complicated, but that's that's taken care of behind the scenes for you.
Yep.
I think we have time for a short demo. I'm going to pop that open. One thing to point out is we've made this, we've learned a lot about how to get people involved in open source. A lot of, one challenge with open source is people don't know how to get in touch, or they don't know where to start. So there's a lot of things that we've done to make getting started for beginners easier. Including, good first issue on our list of issues. So if you come to our GitHub issues, there are things that are tagged with good first issue. You can get started. You can get on the mailing list and get involved. We also have some examples here. We want to keep adding to these. When you come to our GitHub, which is GitHub Apache Mahout, you pop open these examples. We have this opening collab button. So you can actually get started here without downloading any code. You don't have to do any builds. You can simply click on opening collab and it would pop open this notebook, which has the simple example notebook, and everything you need to get started is included. Eventually we'll have pip install Qmat, which would be pulling from PyPy. For now, we have it pulling from our GitHub branch. I have this pre-run because this takes a little bit of time. And once you get everything up and running, then you can import Qmat. You can create a backend. And this is where we were saying the only thing you need to change to switch backends is to change this config here. So you could change this to bracket, or you could change it to Circ, whether you wanted to run on IBM or AWS or Google. You can choose what type of simulator, and then you can do a little bit of tweaking here as well. So it's very simple. You make a new circuit. You can create an empty circuit, and then here, this is what building a circuit looks like using those logic gates methods we showed before. You can put this matrix in, apply this matrix, put this matrix in, then you can run the circuit. And here what comes out is this is a representation of the values in each of those 0 or 1 vectors. So this is what comes out of this simple example. We do have some other stuff to show in just one second. So here is an example of using Circ instead. So very clean, very straightforward, and it's a great way to get into quantum if you have any curiosity about it, if you want to take it for a spin, see what it's about. And like we've said, if you're interested in writing machine learning algorithms, this is basically a green field that has a lot of room for beginners, for people who are interested in having a big impact on a project. Coincidentally, when we gave this talk in Brussels at FOSDEM in February, the talk after us was a vendor who has been doing this for about 7 years, and we've talked with them a little bit. And we're pretty confident that a lot of people doing this don't have the bandwidth to write the algorithms themselves. So there is a lot of value here to be driven to build out this new paradigm of computing. So again, questions, if you have any questions, they'll be fed to us afterward. Just to get us back to the slides here. Here's some other screenshots of other versions of that example. We have the draw method here. So we've been talking about circuits a lot. This is what circuits look like. So you have your qubits, and you have is a Hadamard gate. I think this is a not X gate. So this is a description of what this. Oh yeah, it's Hadamard and not, and then poly. So what we have here is it's built up into a circuit of matrices that are multiplied together. And then in here, there's a few measurement steps, and those are pulled back out, and then it shows your measurement at the end. So that's something else we have going. I don't know if this method is in Qmat yet, but there are a lot of visualizations for what qubits look like. So we feel like, as we've been doing this, like Trevor said earlier on, we're not quantum people. This is new to us, but we're the type of engineers who enjoy learning as we go. And so we've been able to learn a lot about how quantum works, what it looks like conceptually, and things like that. So there are other, visualizations of qubits that we will be including. So it's actually a good learning tool as well if you're interested in getting involved. And so wrapping up, we have measure methods. I am not sure measures in there, but I think I'm wrong because I did see measurement happening. Some use cases, that's something that we have laid out on a roadmap. And when we've talked to people like QBraid, who's the vendor we've spoken with, and other people, there are lots of use cases in pharmaceuticals, in other industries for where this is useful. And we'd like to build out those. We'd like to build out more examples. And then the main drive for the next few years, we believe, would be building quantum machine learning methods. So that's pretty much, like I said, an open field. There is a ton of room to get involved. There are basically, to bring quantum machine learning up to where traditional machine learning has been, is available to the community. And then, so how to get involved, Trevor?
We have traditional Apache. You can join the mailing list. I believe, did we turn discussions on the Git repo? I can't remember.
Yeah, I think so.
We have weekly community calls. But if you want to just check it out, definitely drop by our GitHub. The collab is free. There is multiple tiers. There's paid tiers, but it's usually to access higher grade GPUs. All because we're not doing GPUs, we're just doing examples. It's all CPU based, and Colab will happily give you free CPU time and a notebook to run examples. So take advantage of that. Or if you're super anti-Google, you can also they're just simple Jupyter notebooks. You can download them and run them on your own Jupyter too, and they should work fine. The Colab was just an easier on-ramp. Another thing that is usually easier for people getting involved is sometimes just doing documentation. It feels like a lot less stressful. Like you can read a thing and say, hey, that grammatically is incorrect, and then do that, or that's spelled wrong and fix that. We welcome those types of things. And again, we're not quantum experts. So, and if you are, and you want to just come in and tell us we're dumb, feel free to read the whole code base and pick us all apart. I will happily take your contribution. And if you want to do something really cool for your resume or your grad thesis project, you can implement some quantum machine learning, and we will help you out with that too. The pip install Qmat, again, will work, is an unauthorized version. Hopefully will be fixed soon. We just got the Qmat name and PyPy reassigned back to us. That's a whole fun thing. If you've never had to do that, it's a thing that you can do apparently. I think we started that back in December, and like mid last week, it just got moved over to us. So that's exciting. Yeah, and play with notebooks. Yeah, just get involved. It's easy. You can do it right now. Do it on your phone. Do it.
Yeah,
do it.
you can. Yeah, so we're trying to make this easy for people to get onboarded and try things out. And like Trevor said, we're always here. Always, we've had a few new contributors in the last few months. We actually have somebody who is doing a large bulk of work improving documentation as a Google Summer of Code project. So that's very exciting. So that, yeah, go ahead.
Oh, I've just in general, if you go and I'm getting a weird echo back.
I think it's the room.
If you go to if you just Google Apache Mahout, you're gonna find tons of documentation about MapReduce, and then a ton of documentation, not as much, but still a bunch of documentation about Scala. It is a problem of a project that has been around for going on 15 years and been through multiple iterations that just happens. So we have a person who's helping out, a new volunteer that is going to even if you go to the website, you'll see a lot of this stuff. So we're going through a big refactor of the website to clean house and say, okay, this was stuff. It is now not what we're actively working on. This is what we're actively working on. So yeah, we apologize for the confusion. We acknowledge that it's an issue. We know.
Yeah, but if you have any questions, let us know.
Yeah, please. Definitely get involved.
So thanks very much. And yeah, I think we have time for QA, if that's true, Sven.
Yeah, that's true. We've got about 5 minutes. Thank you, Andrew and Trevor, first of all.
Thank you.
For that very insightful talk. Yeah, are there any questions in the audience? I can only describe to you what I see. I see a couple of long faces. I'm pretty sure if any one of you has some questions or additional thoughts afterwards, they can just shoot you a message on the Mahout website, and then you will get back to them as fast as possible. All right.
Yeah.
Roman said he was going to be there dancing, so if anybody finds him, make sure to give him a hard time, because it seems like he has not made good on that promise.
All right. Thank you again. Thank you very much for your time and for your insights.
Thanks for coming. And thank you for hosting.
We will have a short break here, 10 minutes, and then we will commence with the last talk for tonight.
Tschüss.